This is lesson 14, activity 3. Alternate interior angles are congruent. And the name of this lesson 14 is actually alternate interior angles. So this is the activity that is going to go through what alternate interior angles are and show you that they are congruent. And this first activity, you're given a set of parallel lines, and remember that this line that crosses them is called a transversal. And they tell you that M is the midpoint between P and Q. And they want you to show a single transformation that demonstrates that angle MPA is congruent to MQB. Now we know that they're congruent because we know that we can take this angle right here and translate it up here, not changing the size. This is what we learned in previous activity. And it will match this angle up here, and that this angle is a vertical angle to this angle. So this angle is equal to this angle, and this angle is equal to this angle. But that's two moves, two ways to think about it. And they want you to do a single transformation. Well, this point M is the midpoint. Gives the idea that a rotation around that midpoint is going to form a parallel side opposite PA, and the angle is going to fit right in here. It will be congruent. So let's see how that works. So once again, parallel lines, and this only works with parallel lines, and you're going to see that in a few minutes. This is called a transversal once again. And we're going to take this angle right here. So where does this angle map to upon a 180 degree rotation, with M being the center of rotation? Rotate it around. So now we're going to rotate it in a counterclockwise direction. It actually doesn't matter which direction you're rotated in. End up in the same spot. It's going to land right there. Remember that when you have a 180 degree rotation, the sides end up being parallel. The corresponding sides are parallel. So this side is parallel to this side. And actually this side right here is parallel to this side. It's just extended, but still parallel. All right, so the angle maps here. So that means that this angle is congruent to this angle down here. So these are called alternate interior angles. Notice that you have a set of parallel lines and the transversal. This angle is on the inside. It's not out here anywhere. It's on the inside. And the alternate angle, if you go across this and alternate over to this side, this angle is also equal. It's congruent. So these are alternate interior angles, and they are congruent to each other. This angle is also congruent to this angle over here, and they are also alternate interior angles. And that makes sense. It has to work, because this angle is going to add to 180 degrees. It forms a straight line with this angle here, and this is going to be the same angle that adds to 180 degrees. It sums to 180 degrees by adding this angle here. So these angles are equal, and these angles are equal, or congruent. So alternate interior angles. They are congruent. All right, but what if the line is not parallel? What happens when the line's not parallel? Let's prove that they are not congruent when the lines are not parallel. So I'm going to take this angle that's formed by, it's MPA, it's this angle right here. But I'm also going to add a few more angles. But I'm going to compare every angle that I make to this angle, BQP. BQP. So which angles are congruent to BQP and which are not? And what has to happen for those angles to be congruent? So I'm going to add a bunch of angles. And we're going to do these one at a time in a moment. So this is line L, it's not going to change. This is line T, it's not going to change. But line K is going to change. We're going to rotate line K up a little bit, make the angle smaller, and we're going to rotate line K this way to make the angle larger. So here are those rotations. And again, we're going to do these one at a time. I just want to show you in one image what it's going to look like. So this is going to be the smaller angle. So if we rotate K this way and make it closer to line T in both cases, then this angle is going to be smaller. So we're making this angle right here smaller as we move towards T. On the other hand, if we rotate line K this way, this angle now is going to be larger. So look at this angle compared to T, this angle right here. And its vertical angle is right here. So this angle now is getting larger. And if we rotate it further, this angle is even larger. So now how do each of these angles compare to BQP? And when are they congruent to BQP? What has to happen? All right, this is the first one. This is the original one you're given. Actually, this is the only one that you're supposed to work with. And if we rotate that 180 degrees, it rotates here. Now remember that these sides would be parallel, so it's a 180 degree rotation. It goes right up against here, but notice that it is smaller than BQP. It's a smaller angle. It is not congruent. It is smaller. And that really is the end of the activity. That's all you were supposed to do. But let's add a few more lines. Take another look. So if we make this line, this angle smaller with T. So this angle right here, I'm going to make it smaller. Get rid of A. Make it smaller. And now I'm going to rotate this 180 degrees. Now remember, I'm going to form a parallel line this way. It's going to go up against this angle right here. So there it is. But how does it compare to BQP? Now it's actually even farther away. There's no way that's congruent, completely different angles. Notice that these lines, though, are parallel. This line right here, this side right here, and this side right here, because it's a 180 degree rotation. All right, so what happens if we move away from T, if we make this angle larger? And if you look, this line now is parallel to this line. So what's going to happen? Well, you guys all know what's going to happen. So here's the angle. I'm going to rotate it 180 degrees, and it's going to match BQP because these two lines are parallel. So 180 degree rotation, this side is parallel to this side up here. So these two angles are congruent, and this is angle BQP. So when you have parallel lines, you have and cut by a transversal, you have alternate interior angles that are equal to each other. Change the color to be consistent with the color that I used in the very beginning. All right, the last one, if we move this even farther away from line T, make this a larger angle. So what's going to happen now? So this angle now is larger. So when this rotates 180 degrees, we're going to get a parallel line to this line. We're going to get a line up here. Actually, let's see how that works. There it is up here. So this line is parallel. I'm sorry, I should have realized that. This line up here, this side is parallel to this side. So this angle has rotated around 180 degrees, but now it's larger, and it's substantially larger than BQP. So the whole idea is to have alternate interior angles that are equal to each other. What has to be true about the two lines? They have to be parallel. They have to look like this. This is parallel. K is parallel to L. So you have alternate interior angles that are equal. This is the essence of the entire lesson. Alternate interior angles that are equal.